clicker. Does anybody have a clicker? One clicker. Got your clicker.
Now the next question. I don't have my keyboard.
So we have the technology.
Good morning, everyone.
Good morning, Mufti. Professor.
Thank you very much for your patience. Well, we're starting a little late, but we'll try to make sure that, well, we cover things on time and you can go, let's say, at the end of the workshop at that time, on time, okay? So here, as David mentioned, that we are focusing on yet another aspect of the toolkit. That is the detection of engagement only using minimal amount of data, which is the videos captured by the webcam connected to a device. Now, of course, well, this is something which has been done as a part of the previous European Union funded projects that we have done under the Erasmus Plus program, mainly the AI Top and Diverse Asia project. Now, in this, I'm going to talk about very briefly about the classroom engagement, how we usually do classroom engagement, then examples of applied AI in personalized learning, because, well, the main goal of this engagement app is to provide a personalized learning pathway for the students. Okay, now because we all are faculty members here, okay, we all have been in the classrooms and we all teach and then interact with the students. Usually we all know that there are two ways that we can detect engagement. The first one is the report driven, okay, of course, not taking into consideration that whenever we are in the class, we can see the student faces and we can understand that who is engaged and who is not. But in addition to that, if we want to document that particular aspect, usually there are two approaches that can be taken. The first one is report driven, where the students or the learners can be provided with a questionnaire, okay, and they would self-report that whether they have been able to engage in that session or not, okay, how impactful or effective that session has been in terms of their learning. The other one is technology driven. So within the technology driven, thanks to the recent developments, not so recent, but, well, this is something which has been coming along a few decades now. So there are technologies such as eye gaze tracking, and then physiological measurements, like because we know that whenever we are engaged, our body has got a very specific signature, and when we are not, it has got a different one. And of course, we can also detect behavioral states from the videos. Now, our focus is actually the second part. Okay, so we are going to talk about that how these specific technologies can be used in detecting students' engagement in a session. Now, to do that, what are the data that we have used? First of all, we have used the data related to the interaction of the learners with the computer, or could be any device. Okay, so if they are working from a portable device such as a pad, iPad, or a tablet, that is also something which can be taken into consideration. So the amount of clicks that they are doing, or the taps, the key presses, what they are doing, and the position of the mouse pointer or the trackpad. Now, in addition to that, we actually consider the emotion or the physiological condition of the student or the attention of the student during the session. Now, what are the specific data that we can use for detecting that? We are using the data from the webcam, the video that is captured by the webcam. In addition to that, I'll come there, but well, this data is used for emotion detection, for eye gaze detection, that where they are looking at the screen and detecting or estimating their heart rate, because this is something which can be representative of what is their physiological condition, how well they are feeling, because you know that when we are anxious, then our heart beats faster. Okay, when we are calm, we are engaged, it has got a different rate. So taking those into consideration, if we can have an estimation of the heart rate, that could be a good estimation. Now, when using these webcam related videos, we can also actually use them to detect the pose or the action that the students are doing, because in certain disabilities, we know that the literature has very well established that there are certain movements and actions that can be considered as signatures of certain upcoming event. Okay? Therefore, when we consider the emotions, eye gaze and heart rate, in addition to the interaction that we said before, that is something which will allow us to detect the engagement of the student in that particular session. With this engagement, when we add the pose and the action, that is something which would also allow us to understand the behavioral state of the student during the session. So for this, we actually have developed a system which is called LE-MATE, so Learner's Engagement Friend, yeah, in that sense. It has got mainly two components. The first one is the engagement and the behavioral state detection system, and the second one is the monitoring mobile app, because well, what we want is that the teachers or the support personnel who are taking care of a class should actually receive certain information so that they can provide real-time intervention if it is needed. Okay? So for the engagement and behavioral state detection system, it usually runs on the computer of the student where the student is working, okay, as a background service, so that while it is not something which is blocking or hindering the activities that the student is doing, so it runs in the background like any other process of the operating system, okay, or any other software, and it is something for which AI or machine learning based models have actually been used. And for the mobile app, it runs on a dedicated portable device which are held by the teacher, for example like smartphones, and it receives, let's say, alerts or information about the student's behavior and the learning states. Now the system architecture. Now let me just very briefly show you that how is the overall scenario. Okay, so consider that there are two classrooms, one is here and the other one is here, because this is a distributed system. Okay, so it can support a number of different classrooms at once. Okay, so within these classrooms there are, as you can see, that there are students and teachers. So the students are having a device that they are working on, and the teachers are equipped with so here you can see that they are working on devices, and the teachers are equipped with a smartphone, okay, or any portable device. Now on the computers of these students, there are this detection system which is running in the background, as we have previously mentioned. Of course, it has got a more detailed architecture that we will see in the subsequent slides. And then when this system is running in the background, it is detecting the student's learning and the behavioral state, and then through the APIs, it is actually sending those into a cloud storage. Okay, so within that cloud storage, the things are analyzed all the sorry, all the further analyses are done, data are stored, and then by the means of the APIs, then these information are communicated as alerts with the students. Thank you very much, sir. Right. Now, very recently, okay, well, because we have been working on this for quite some time, so very recently we have got it published. It's just out of the press, okay, and just to let you know that the core engagement detection system has got 5 components. The first one, as you can see here, is the interaction, okay, with the computer. It considers the key press and the pointers. Then we have the eye gaze tracking, the emotion detection. Then we have the heart rate estimation, and finally the engagement of the student. So this is something which is giving us the learner's learning state, and this is something which can be categorized into 3 different categories, which have been very well documented by the educational scientists. That, well, usually this is something which can be understood as a traffic light system, that whenever someone is engaged, it's a green, and then when someone is bored, it's amber, and when someone is frustrated, it's red. So based on these specific things, there can be, let's say, personalized material delivery which can be planned. For example, let's say that, well, if someone is, for example, let's say that, well, because we are all technologists, you are teaching, let's say, AI to the students, okay? Now, AI can be taught from multiple different perspectives. Let's say that if you are teaching it from the very mathematical perspective, you see that the students probably are not really engaging at the session. So how can you then modify it on the fly through, of course, certain other systems or algorithms that you later on integrate with this? Can that be then represented in a more, there's a descriptive manner so that the concepts are understood, but probably, well, they would then gradually learn about the mathematical aspects of those specific concepts. So maybe changing the delivery would bring those students back or engage those students back to the session. Okay? Now, so the detail of the session, I would request Professor Shamim Kaisar to please come. Yeah. So for the model.
Thank you, Mufti. So, in our model, we are collecting 2 types of information. One is actually engagement information through keyboard, mouse. When we are interacting with our exercises, we always move mouse, right? And we click something in the keyboard. So this information has been captured. The key press, pointer position, and then we are also collecting information using our webcam. That is, we are collecting video information, and then from this video information we can pick some frames, right? So from that frame we can calculate the eye gaze information as well as the eye tracking, eye gaze pattern as well as eye tracking using the machine learning algorithm. So
let me just very quickly comment on that, because you see that, well, the literature suggests that whenever someone is attentive or actually following the content which is present on the screen, how they look at the screen, that particular pattern changes. Now, if you take that, well, this is a screen, and each of these circles are the area where the students are looking, okay? So as you can see that here there is no pattern, right? So everything is jumbled up here and there, which means that, well, there was no specific pattern that the students was looking at the screen, okay? While whenever the student is focusing on certain components or certain aspects, for example, reading certain materials, you could see that there are very specific patterns that emerges than where the student is looking at the screen. That is why having that eye gaze tracking actually can be an initial indicator that whether the student is really following something on the screen. Okay, because as you know that when we are browsing through the documents, we look here, there, and all. But when we are reading, we are actually following a specific way of looking at the screen, right? Please.
And also we are, calculating the emotional information like happy, angry, sad, and frustrated. So this is another flow. We can also calculate heart rate from our facial information. So if we merge this information, we can measure engagement. So the student is more engaged, bored, or frustrated. The traffic light. And also, using the machine learning, we can detect the action information. So let's say the movement of the hand, the activity of a person. So using this information, we can calculate the meltdown detection using the another machine learning approach, which is called a neurophagy system. So we can comment that, okay, the student is happy with the content, or there is a possibility of meltdown, or this kind of information we can calculate using this.
Okay. So
Oh.
right.
This is one student.
Good morning, everyone. So, at the beginning of the journey, we found that yes, we can detect the engagement in multiple ways. Okay, that time it triggered the sense like let's explore what are the modalities we can incorporate. Okay, so Mukti started with the concept like yes, we can go with the video camera because we know we have some other tools, but we also try to minimize our tools because let's say if we are adding the peripherals or something like that, that will bring some added restriction as well. And if you are thinking a spatial domain of a student or a spatial need, student with spatial need, they may not be very comfortable with the new wearables. So we try to particularly look on the camera that we have integrated inside the laptop. Now, this is something, it was very preliminary. With a few lines of code, we can do that. Like, we try to see, okay, if we are tracking our just eye, okay, we can say something very nicely, like, yes, there is a small demo here. You can see that at the left, it is saying something, looking left, looking center, not focused, looking right, looking center. Okay, so this is something to begin. So that was the first idea that we thought about. Yes, this is one of the way we can collect the data and try to measure it. Okay, we developed it long before. Okay, but that was the beginning of the journey. Then we tried to increase the modality. So if it's a modality in a sense like the video camera, but it's going to be calculated in different way. Let's say we have multiple ways, then we can bring them as a voting system again and try to figure out, are we really confident whatever we are saying? Okay, so I think you will see the journey will progress even further. So this was one of the initial stage that yes, we can detect just based on the eye movement, engaged or not. But that is not all. That was the very beginning. Okay, Mukti.
Now you see that the whole point is that there are other sophisticated technologies that are available for eye tracking. Okay, so eye gaze detection and all these. However, what this particular example shows is that it is the video That's what we need. Okay, so if we have the video, we can also track the eye movements. Of course, well, it might not be as accurate as the eye tracking system would provide, but considering the classrooms with low resource settings, I think that this is something which can be very, very useful. Right, now here is the emotion and the heart rate estimation, but this is something which uses the RPPG signal. Okay, so it tries to estimate mainly the blood flow. You know that whenever blood, our heart pumps, there is certain amount of blood which is being flowed to our face or all around our body. Okay, now from this particular video we can actually detect the change of color, okay, of our face, and that is something which can then be used to estimate that how often that color changing is happening. Okay, therefore that can be then correlated to the heartbeat. Okay, and that is, of course, it's an estimation, but we have tried to let's say apply wearable devices just to understand that whether this is something which is providing a realistic estimation or not, and we have seen that that is something which is quite comparable, of course, with certain margin of error. Okay, sorry. As you can see here that in that photo, that BPM is actually the estimation of beats per minute. Okay, so that is something which is being shown. Okay, and of course at the same time you can see the emotional states there as well. For example, as you have said that there are several emotional states that we are detecting, and among those are neutral, angry, happy, frustrated, etc. There are 6 specific emotional states that we are detecting. Now this is actually nothing new. Okay, that is because, well, there are a number of different tools which are out there that allows us to detect emotions from the facial expressions, and we have used such a tool called the MediaPipe. Okay, and that MediaPipe has got a specific component that allows us to detect the emotions. Now this is the learning state detection, and then this is the demonstration of the initial system. Okay, now as you can see that, well, the initial system, when it starts, because it needs certain data to calibrate to the learner, right? Because it needs certain data to calibrate to the learner, initially for first 2-3 minutes it collects the learner data who is sitting in front of the device. Now once that particular data is collected, the system is calibrated, then it starts its work. Now there are each of these specific buttons that you see here. They are designed to demonstrate the individual components only for the demonstration purpose. Okay, otherwise, well, the button that you see, which is grayed out, that you will see very soon, is the one which actually starts the system. So just for showing or demonstrating the individual components, we have created these buttons. For example, this shows the mouse interaction. As you can see that whenever the mouse is moved, the mouse's these coordinates are moving the current position, and for example here pressing the keys, well, you can see that how many keys have been pressed. Now the one point here is very relevant to mention. Okay, that is, we are not storing the key presses. Okay, because whenever you press keys using the keyboard, you actually, for example, type in your passwords. Okay, so we are not trying to understand what your passwords are. What we are trying to see that what is the rate of your typing. For example, if you are typing in a constant, let's say in an engaged manner, then you will have a specific pattern of typing, the number of letters that you are typing per second. Okay, it could be, sometimes it could be very slow, sometimes it could be very fast. So if it is very slow or if it is very fast, those are the things which would then indicate that probably the learner is not really engaged to the session. Okay, so by no means any of the data that is entered into the system are collected. Okay. Right, then, well, at the initial stage, as you can see there, well, from the facial expressions that you can see there, it can then identify the emotional states. And then the next one is the RPPG measurement, okay, so that, well, how can it estimate the heart rate, okay. So as you can see on the corner here, so that is how the image processing is taking place through a number of different phases, and through this image processing, the facial color change can be detected, and that is something which can be then associated to the heart rate. Now here for these, as Dr. Arif mentioned, that, well, there are other methods that have been developed to identify the eye gaze and eye movement. Okay, so this is something which is used to identify the eye just to see that whether the eyelids are closed, okay, and which particular direction the students are looking at, and that is something which gives us a good indication of the engagement. Okay. Now here, as you can see, that they agreed to the terms and conditions that, well, initially certain data will be collected, so they agree with that, and then there are certain input that are being provided. Once those input, like the class ID, the teacher ID, etc., these kind of details are provided, and once those are provided, then the system starts collecting data for about 3 minutes. Okay. Now this is something which happens at the background, and during those 3 minutes, for example, the learner goes to the learning materials, and then they, for example, in this particular case, they are browsing through the different materials, so as if they are doing their normal activities with the system. Right. So once, just let me fast forward it a little bit. So once, let's say that, well, all these data are collected, that is something which is used for the calibration. Okay. So after certain time, so once this timer of 3 minutes expires, then we know that these basic baseline data are collected, so that, well, we have a stable estimation of the heart rate, okay, stable or reliable estimation of the emotion, and the interaction, that how the interaction is estimated. So of course, well, this is something which would then use, which then can be used, for example, identifying that in a continuous basis, at a continuous interval, okay, that whether the student is engaged or not. Okay, and that is something which would then, for example, here, as you can see, that there is a green light, which means that the student was engaged, and this is something at a timely interval will be sent to the teacher as an information that, well, which students were engaged, which were not engaged. Okay, now that is where actually we then move on to the second prototype of, let's say that, well, can we extend these information to also identify the students' behavioral state in the class. Why is this important? This is important because if we are dealing with a student with certain conditions, for example, the autism spectrum disorder, autism, okay, in short. So we know that there is a particular state which is called the meltdown state, where the students are emotionally dysregulated. We very often say that, well, they are at a hyper state. You know, hyper is the terminology that very commonly used in this part of the world, that the students have become hyper because they have lost control over their emotional regulation, which means that they cannot control their emotions anymore. So they start throwing things, they start shouting, crying. You know that there are different manifestation of that particular manifestation of this. Now, can we use such system in addition to the actions that they perform in the classroom that are being captured by the webcam to actually identify that whether they are actually reaching that particular stage or not? Because the literature suggests that if someone with autism reaches a meltdown stage, it can be very detrimental for their physical and mental health as well. Okay. Therefore, of course, not to mention the classroom disruption that will happen. Okay. Therefore, what we aim to do is that if we can identify that the student is approaching that particular state, then certain interventions can be let's say can be taken or can be placed to ensure that the students do not reach that meltdown event, and then that can be diffused early on. Now, this is something which we have developed, okay, as a privacy preserving mechanism as well, because many of these systems, as I mentioned, for autism, okay, and these are vulnerable subjects, right? Because they are vulnerable subjects, for the analysis and whatever it is, we are using the videos. But if we want to store these information, share with someone else, or even use them for further model development, it is very dangerous to share the personal information. That is why the benefit of such methods is that instead of sharing the videos, the equivalent cloud points are estimated. So there are specific landmarks, okay, of the image, okay. For example, in this particular case, as you can see, that the faces has been meshed and certain landmarks are being established, and these landmarks are collected and stored, and the videos are discarded. Now, this is something which is very useful for sharing the data, okay, for further development of the AI models, and also for protecting the privacy of these vulnerable students. And that is what makes it very, very interesting. Now, here is yet another demonstration that how this is something which can be used for detecting different actions. For example, here you can see that the face has been landmarked with a number of different points, okay, and only using these points it will be possible to actually detect what the student is doing who is sitting in front of the webcam. For example, we have tried to identify certain actions. Now, these actions are the ones which the literature suggests related to the meltdown event or the pre-meltdown event, which is called rumble event for the students with autism. Okay. So when we see that the student is doing something like that, which means that there is something which is coming up. Okay. So that serves as an indication, as a signature of the meltdown happening in the next few minutes. For example, the covering ears. Okay, as you can see that this does not only detect the facial landmarks, but it also actually detects the different limbs and the body parts as well. So head scratch, so the bottom line is that in addition to the learner's learning state and this kind of action, it would allow us to identify the students with autism who are actually reaching the meltdown event or who are approaching the meltdown event, so that they can be necessary intervention can be placed to diffuse that particular situation. Right now, as you have said that the behavior in this particular case could be again could be represented using a traffic light system. It could be neutral when it is absolutely fine, everything is going well. You know, it could be a rumble moment, as I said, that well they are actually not well, they are going towards even a worse situation, which is the meltdown. Okay, when well they do not have any control whatsoever on their emotions. Okay, so the emotional dysregulation takes place. And of course, in addition, well, we, as you have seen in the previous system, we can also have the learning states, that whether a student is engaged, bored, or frustrated. Now, this information would then be shared to a specific mobile app. Okay. Now, as you have said, that this mobile app would have the specific details of the teachers. Okay, that which is the classroom, and then they can connect to the system then, and they would have two different important aspects, which are historical, longitudinal, which means that well it is not only about the current classroom or the current session, but they can also have information about the previous sessions, and they are the learning states, and if there has been any alert about that particular student. Okay. Now, when we talk about the learning states, for example, there could be the behavioral, the states, there could be the behavioral states and the learning states about all the students who are present in the class, or who are actually looking or working in that particular system. Now, when each of the students are selected, then their behavioral state and their learning states are provided. And in terms of the alerts, okay, now the students are sorted as per of the specific alerts that are potentially there, and whenever a student is selected, then there could be their physiological parameters, or all the data that have been collected about the students can actually be shared. For example, let's say that well what was their heart rate, okay, the physiological condition, what was their emotional situation, what was their behavioral state, and what was their learning state. And this is something which the teacher can take into consideration to support the students. Okay. Now, in conclusion, okay, I would like to again just reiterate this. We cannot actually emphasize this enough, that education plays an important role for an inclusive society, and we would like to make the society inclusive, and well, now as you all are here in the inclusive education workshop, so that therefore, well, this is something we can all agree. Now, classroom engagement is necessary for the next generation, given the tools that we have of the education. Okay. And it can foster personalized learning, and the privacy preserving approach would then allow us to even further develop the systems, the current challenges that we have, and it will facilitate the equitable support in a classroom. So with this, I'd like to thank you all for your attention. If there are any questions, you can take some questions.